Hello, time travelers. Jensen Huang recently did a keynote at CES explaining a whole bunch of stuff about the new Blackwell series GPUs, and I've got the full breakdown for you. Also, last year when he went on CES to talk about the 4000 series super GPUs, I did a video on that, and some of my viewers are still saving up money for one of those GPUs. You guys, you need to watch this video and decide if you're going to keep saving for one of the 5000 series GPUs or if the GPU you've been looking at is still the one you want to get.
The voltage regulator design is state-of-the-art. RTX 5070, 4090 performance. This 5070 laptop has a 4090 performance. We're going to shrink it and put it in there. Does that make any sense? For that is because we're generating most of the pixels using our tensor cores. Wait for it.
In this whole keynote, it's like Jensen doesn't know words or how to talk. Like he says memories instead of memory modules and other flub-ups. This is my look of disapproval.
6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history.
They discovered CUDA? Like what? Under a rock? After many eons, that scientists are guessing was probably about 6 years later, when everything about NVIDIA had become forgotten lore from the before times. Some researchers discovered CUDA.
Well, GeForce brought AI to the world, democratized AI.
America! Wait, what? Did he say democratized? Introduce democratic system or democratic principles too. That's what I thought. Make something accessible to everyone. That's more like what he said, but I'm getting a different vibe right now. America! Hey, it's future/editing me here. See, different shirt. But Jensen says democratized. Seriously? You didn't democratize it. People have to buy NVIDIA hardware in order to run it. It's not available to everyone then. Some people can't afford it, and some people can't run it because it's in conflict with something else in their system. And I'm just gonna stop right there. So I call nope.
Nope.
Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
Coming in like a spaceship for some reason. The GeForce RTX. Smaller than the predecessor, but we're trying to make it look huge. Ooh, it's flying apart. Is it a transformer? Or is it broken? No, it's two drones.
All right, this is what I want to see. VRAM DIMMs, or our modules. Okay, if we pause it and count them, I see 16 modules. And those are probably 2 gigabyte modules, so 32 gigabytes of VRAM. I'm hoping that all the VRAM is on the same side of the PCB as the GPU, because sometimes NVIDIA does this goofy thing when a new type of VRAM comes out. They stick half of it on the backplate side, and then under certain workloads, the GPU will overheat and throttle itself, like the 3090. I found this article on Tech Power Up. They actually did a teardown of the 5090, so let's check it out. Okay, yeah, there's the front. By the way, it's got fans that go all the way through. Pass-through fans, they call it, because the GPU's in the middle. That's cool, but that's probably why it doesn't have a big chonker cooler like the 4090. There's the other side. Oh, that's a much better picture. Oh yeah, 16 of them, probably 2 gigabytes each. Let's see if they got the other side. Oh, thank you. Here's the backplate side. Interesting. No memory modules here. That makes me very, very happy. Reversing the CES video and pausing it at just the right spot, we can confirm this is the same PCB layout. So I'm excited, actually. I might get one of these if it's not unobtainium.
Maybe not the laser, but the impeller.
From where?
The heat of the core. It's 9,000 degrees.
Unobtainium converts heat to energy. So this whole damn ship's like a big old solar panel.
Coming in like a spaceship for some reason. The new RTX Unobtainium. Paper launch available soon. At ridiculous prices that will probably be inflated by scalpers.
Our brand new GeForce RTX 50 series Blackwell architecture.
Zoom and enhance, because I caught myself trying to see the GPU he was holding. Because I thought he was gonna do like he did last year, never actually say the GPU model number, but he does say it in a kind of mumbly way.
This is the brand new RTX Blackwell 5090. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art.
The voltage regulated the design? I think he means they redesigned the voltage regulators. Sigh.
Well, now, with the Blackwell family, RTX 5070, 4090 performance at 549.
Wait, he was talking about the 5090 before and holding it in his hand. And now he's talking about the 5070 having 4090 performance? We'll see about that. Well, let's look at the number of CUDA cores here. The 5090, which he had in his hand, has 21,760 of them. And the 4090 has 16,384. But the 5070 that he says is 4090 performance is only got 6,144. It's like, what? Oh, okay, the 5070 has a similar base clock to the 4090. That might be how they're pulling it off, combined with the AI stuff that we talk about later in this video.
Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories.
These are memories.
Whose memories?
Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. So can you imagine? You got this incredible graphics card here, Blackwell. We're gonna shrink it and put it in there. Does that make any sense?
Yes, I can imagine you putting a desktop GPU in a laptop. I have a vivid imagination. But that's not what you did. This is how I got all the specifications for today's video. I just go on Google and I put tech power up followed by the model number. And let's look at the 5090. I'll open that up in a new tab. And also the 5090 mobile. It's not the 5090 laptop. It's called the 5090 mobile. So here's the 5090, the desktop one, and it uses a GB202 as the graphics processor. But let's look at the 5090 mobile. Uses the GB203. That is not the same graphics processor. If you scroll down and you click it here, scroll down some more, you can see all the actual GPUs that use that processor. 5070 Ti, 5080, 5080 mobile, 5090 mobile. I'll give you this, Jensen. You figured out how to put a 5080 into a laptop and call it a 5090. But that's not something new to NVIDIA, is it? You always do that. So let's take a look at the 5070 mobile, GB206. Scroll down. It's 5060 mobile, 5060 Ti. What? After all this work that I did on the script for this video and chopping up bits of Jensen's thing to put into my video, there's also a 5060 and a 50 Ti? What else is going on that we don't know about? I've got some graphs here so we can look at the currently announced 5000 series along with the mobile variants. Your AI chops will scale up evenly here up until you hit the 5090, which just jumps really high. It makes me feel like next year they'll announce a couple GPUs that are between the 5080 and the 5090. If we look at the tensor cores, you see how it scales up just as well again and then jumps. And going over to CUDA cores, it's doing the same story. But you get an idea of the performance that the laptop GPUs might get compared to their desktop variants. So you look at the TDP. Okay, now if the 5070 mobile base clock is this as good as it shows here as the 5070, but it's pulling less than half the power, either it's more efficient or it's not actually going to be able to perform. And you can pause the video here and look at, and check this out, or you can check me out on Patreon and I'll have this in my tier 2 folder. But I'm really, really curious about the tensor cores and the performance there. 8 gigabytes at the low end for the 5070 mobile. But we don't know if they're going to have like 5050s or 5060 mobiles in the future with a stupid 6 gigabyte GPU in there, like my 4070 mobile that I have in my new laptop. You can click the card up here on the top right of the video and watch that later if you want, where I talked about my new laptop. 12, 5070 for the price of this thing. I think it should have more. 5070 Ti mobile. That's really cool to have 12. 12 in a laptop is sweet. 32 in the 5090, that's another thing that's making me just want to save up and get this thing. That'll make it a lot easier for training things with AI that have large batch numbers. Now looking at the base clock graph, it's not the same story. It doesn't scale up and then jump all the way to the sudden when you get to the 5090. So this might be a reason for some people to save up even extra dollary dues so they can get the third-party GPUs that have a bigger cooler on them so they can overclock.
Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate, using artificial intelligence, all of the other pixels we have.
So we generate all the pixels we have? What?
And what's really amazing is the family of GPUs we're going to put in here. And so the 5090...
Wait, there's that silly new spec again. AI tops. What is that? Why is that on the slides? The GeForce RTX 5090 GPU, the fastest GeForce blah 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 blah, features 92 billion transistors providing over blah 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 trillion AI operations per... Okay, here we go. AI operations per second. So the T is trillion operations per second, but AI isn't in there. So AI trillion operations per second. They're saying AI tops. Blackwell architecture innovations on DLSS4 mean the GeForce blah 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 outperforms the other blah 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 up to 2x's. Whenever I miss my X, I think about 2 X's ago. My XX. Good riddance.
Here's a pandemic as shoes.
What'd you say? Okay, artificial intelligence obviously needs tensor cores, but he didn't show it in the slides. It just says like AI tops, which I did my research and I was able to find an NVIDIA page that listed the AI tops for the 5000 series and the 4000 series, and that same page didn't want to tell us that same specification for the 3000 series. The 5090 is ridiculous at 3400. And that's more than 3 times than what the 5070 has. And the 5070 is still got less than the 4090. But looking at the graph for the tensor cores, the 5070 is still way behind the 4090. I'm not sure if the 5070 is going to beat the 4090 in AI tasks or gaming.
The 5090 will fit into a laptop, thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070.
But those are just made-up names because we know the truth now, since we have Tech Power Up to show us reality. And I discovered that there's a 5060 mobile. I was just talking about that. What if there was a lower model? At least it's got 8 gigs of VRAM and not 6. I wonder why Jensen didn't talk about this.
It's a secret.
But I want to show you something that I discovered. The 5090 mobile is very similar to the 3090 Ti. Same number of tensor cores, same number of CUDA cores. Base clock is slower on the 5090 mobile, and the watts are lower, obviously, because, you know, it's a mobile GPU. Memory size is the same, memory bus is the same, memory bandwidth is a little bit better, and the memory clock is a little bit better as well. So, imagine having 3090 Ti in a laptop and calling it new and having to pay $3,000 for it.
I'm not impressed!
Let's take a look at Blackwell.
Huh? I thought we were talking about Blackwell already.
Well, Blackwell is in full production. Every single cloud service provider now have systems. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations, Blink 36, CPU versions, NVLink, so that we can accommodate just about every single data center in the world.
So you're putting all the GPUs in cloud servers, just like I talked about in my last 2 videos. Because Jensen gives all the good VRAM to corporations for the freaking cloud servers, for their AI services. I've talked about this stuff in previous videos. A really good one, if If you want to learn more about VRAM and why it's so important in a GPU, check out this video here. I'll have the card. Wait, I'm pointing both ways. The card goes up here, and this is my preview of it. It's a video I did about the RTX 3060 12 gig and how back then it was a good GPU for AI, and it still would be. And I bought one, and I'm still using it.
You don't ever want to reach your hands into a dark place. Hang on a second, is this a good idea? All right. Wait for it. Wait for it. This NVLink system, this right here, this NVLink system, it is 1.5 tons, 600,000 parts, approximately equal to 20 cars. It has a spine behind it that connects all of these GPU together. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink. And we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories.
Whose memories?
14 terabytes of HBM memory.
The first and last consumer GPU to use NVLink was the 3090. It replaced SLI for multi-GPU setups, and what that allows you to do is share the pool of memory between them. So imagine training Allura or some other AI model with 48 gigabytes of available VRAM.
We would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you.
But what does that mean? AI in your home computer. AMD has CPUs that reportedly do AI. My new laptop has a CPU in it that can do AI as well, but I haven't seen anything I could download from GitHub and run on it yet.
This is NVIDIA's latest AI supercomputer, and it's finally called Project Digits right now. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA's software runs on this, and it's wireless or connected to your computer. It's even a workstation if you like it to be, and you could access it. You could reach it like a cloud supercomputer, and NVIDIA's AI works on it.
Maybe this means NVIDIA is trying to change the motherboard architecture, or possibly start competing in the CPU space. I don't know. So it says it can be a workstation or used remotely. Like I've heard of people training models using the GPU on a remote PC in their house. This is my look of, that's suspicious. Can I run Stable Diffusion on it? LLMs? But there's no cooler on it. He said you could use it for various things, but how with no cooler? It looks alpha. He said it would be available in May, but press X to doubt if anything AI will ever run on it. But check out this one slide from the keynote. He mentioned that it has 128 gigabytes of VRAM. Can you imagine running SDXL or Flux or SD 3.5 on this thing? It probably costs a fortune. I predict that it will be very niche and very short-lived, and people will forget about it in a few short years. Boyos on the Discord channel did some research for this video, and he discovered a few videos where YouTubers were getting a little emotional, and one of them was scared of the RTX 5000 series.
There's just something that's really, really bothering me about the NVIDIA RTX 5000 series. Not the GPUs themselves, but more what NVIDIA is trying to do, and I think that bodes ill for PC gaming.
His title says he's scared, and you should be too. Well, I'm going to tell you that FUD is something that you should always be concerned about. His kind of FUD.
What am I talking about? I'm talking about their entire DLSS 4 and the way they position DLSS 4 and frame generation as real frames.
Wait, who is he quoting? I don't remember Jensen saying real frames any time in the keynote. I watched the whole thing. Well, DLSS 4 is a new technology. It's going to have growing pains. Right now, it's just fancy marketing. This guy that's so afraid of the 5000 series, he should actually look at the specs. So let's just look at a couple of the specs between the 5070 and the 4090. Tensor cores, much less on the 5070 versus the previous generation 4090 top level card that NVIDIA is saying this is going to give you the performance of. CUDA cores is way less than half what the 4090 had. Base clock is similar, but it's got half the VRAM as the 4090. NVIDIA is obviously doing their own type of sensationalism here.
Let me focus in on what I'm at here. That at some point, the hardware companies, the game developers, somebody was going to start telling gamers that faked frames are the same thing as real frames. And that's where your FPS is coming from in the future.
Sometime in the future! Think about ray tracing when it first came out on the 2000 series GPUs. Actually, I think this new DLSS 4 is a new feature that is either gonna, 1, flop, and not likely. Gamers won't notice the difference if it actually looks good, or 3, they'll notice that it's a little weird in some way, like ray tracing, RTX, whatever it was in the beginning. Or 4, this is a very highly likely one, it will take a few years for game developers to properly utilize it, like older versions of DLSS and ray tracing and every single little thing NVIDIA has ever introduced that was new. Everything takes time.
6 years later, 20 years, 30 years later, 6 years after that, we invented CUDA. And it took years, in fact. It took approximately 6 years.
If you're going to make a video about being scared of a new feature, maybe you should take a look at the past. Jensen shows us this video that he says was rendered in real time using Blackwell. But is it a server part or a consumer part? Well, that's a secret, because he didn't say. It could be a custom setup with 500 Blackwell server what's-its all NV-linked together. But it just looks like an E3 demo from 10 years ago to me, which looks really good, but it's like seeing a concept car for the car that's never going to get made. Or what the car the manufacturer actually makes in a couple years looks nothing like the concept car. But I also noticed a couple of things. I saw weird motion blur with image doubling. And for the slower segments, they only hold a single scene for a few frames before they skip to something else, like another camera angle or whatever. That makes me feel like they rendered 3 frames and let AI fill in the rest, and they cut to another render before the current render farts all over itself and barfs all over the screen. Because when you're gaming and you're moving your character around, the camera doesn't cut away to another angle or to another scene, only in, cut scenes. It's like TV shows and movies do that, not gaming. Jensen's hiding something. It's like this whole presentation was aimed to impress investors, not consumers. I almost said gamers there. And it shows a generated face with the annotation, RTX neural faces. That literally looks like a JPEG that's been upscaled because it looks super smooth. Like this random image of some celebrity editing me will find later. Before and after. See, if it's too pixelated in the before, then when you upscale it, it just looks all bleh. This is my look of not being impressed by your shenanigans.
That was real-time computer graphics. It would have been impossible without artificial intelligence. We used, of course, programmable shading and ray-traced acceleration to produce incredibly beautiful pixels.
I do love me an incredibly beautiful pixel, like that one there. That one. Zoom. Enhance. Zoom in some more. Enhance. Zoom. More zoom. Yes. Isolate that pixel. It's so... Oh my God. That square of brown is so beautiful. It's perfect.
We have artificial intelligence be controlled by that pixel to generate a whole bunch of other pixels.
That's a lot of brown.
Latest generation of DLSS also generates beyond frames. It can predict the future.
The future! Now, let's talk about power draw. I never really wanted to get the 4090 or any of those higher end GPUs from the 4000 series because of their huge power draw and how big and chonker and badonk they were. And I knew I wouldn't be able to fit one in my case. I don't want to get a new case. Stop telling me that. But when I saw the 2-slot 5090 Founder Edition in this keynote, I got excited. Then I looked up the 5090 on Tech PowerUp, and its peak watts / TDP is 575 versus the 4090's 850 watts, which is redonkulous.
Man, you are a catastrophe. And you are redonkulous.
Before I think of buying one, hold on while I get one of those watt monitor outlet thingies and test my computer and every other freaking thing in this room and anything else that might be on the circuit in my house. I have to figure out what else is on the same circuit in my house. Make sure I'm not going to throw the breaker just by gaming or streaming. But the 5080 went up by 40 watts versus the 4080 and the 4080 Super. And the 5090 went up by 125 freaking watts. All right, a quick self-promo section for this video. I've got spreadsheets and charts and things, and I'm going to convert these charts into images and these tables into Google Sheets and stick them in a folder on my Patreon for Tier 2 and above. Tier 1, they gets access to all the LoRa's that I train, and I do tons of LoRa's. If you scroll down, you could see all these, how they say locked. It's because you have to be a Patreon subscriber to see what LoRa's came out. And on and on and on and on. There's tons of them in there. Tier 2 gets all my prompt images with the metadata inside, so you can see what prompts I use to generate my images, and also all my documentation and scripts for a lot of my videos. Tier 3 gets my training data sets, so that you don't have to go and download a bunch of images if you want to train your own LoRa off of the same celebrity that I did. So if you think this self-promo's been too long, and I just kept talking after you've already been sold, then go into the comments of this video and put this.
Shut up and take my money.
More tensor cores, CUDA cores, and VRAM. I'm really liking the number of tensor cores on the 5000 series GPUs. Why are tensor cores important? Well, let's take a look at Wikipedia here. In machine learning, the form tensor informally refers to the concepts of organizing data in a multilinear transformation. Data may be organized in a multidimensional array, formally referred as a data tensor, however, mapping over a set of domain vector spaces to such as images, movies, volumes, sounds, and relationships, among other words, concepts are stored in... Anyways, tensors are in AI, okay? I've got a mix of GPUs here to give you a better frame of reference. The RTX 3090 with 328 tensor cores. You're going to have more than double that with the 5090. The 5080 is a little bit less than the 3090, but you know, it's only 5080 series. It's going to cost a lot less than when the 3090 came out. 4090 is a good deal if you can fit it in your case and power it somehow without starting a fire. But 4070 Ti Super is probably going to be faster than the 3090, even though it's got less of these cores just because it's a new generation. Well, we also want to look at CUDA cores. And it's a similar story going on here. If you've already got a 4090, look, you can hold on to that for a while. It's going to be better than most of the 5000 series GPUs except for the 5090. And it blows the 3090 and the 3090 Ti out of the water. But the 5090 has 21,760 CUDA cores versus 16,384 on the 4090. That's an over 32% increase. When the 5090 at 1,999 versus the 4090's release MSRP of 1,599, which is only a 25% increase. And the VRAM, 32 versus 24, that's a 32% increase. So the value for the dollar is actually good. That's kind of weird.
This is RTX 4090. It's $1,599. It is one of the best investments you could possibly make.
For a couple of years until the 5090 comes out, because that's the 4090 that you're showing me there.
For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right?
What? I maybe spent $10,000 building all the computers I've ever built since I started building them back in 2002. It's still probably well below that. Unless you count all the GPUs that I was buying and selling while I was doing crypto mining. 10,000?
Don't tell me that's not true.
It's not true.
Well, now, with the Blackwell family, RTX 5070, 4090 performance at $549.
4090 performance. at 549. And why is NVIDIA doing this? I have a theory. I got an idea to build a spreadsheet that shows the value per watt. Let me show you what I'm talking about. All of these ones that are bolded, I added up. So 192 plus 6144 plus that, plus this, plus this, plus this, plus this. And then it says all bolds. That's that number right there. You see the formula. But then it made this really crazy exponent. So all of them are divided by this giant number, just so I can have a baseline calculation. And then you take the number of watts that the TDP is and divide that number into it. So it's like when I'm shopping and I see two things of the same product, but they're different sizes. And it's like they're tricking you into buying the bigger one because you're paying more per ounce. What you do is you take the dollar price and divide it by the number of ounces and do it on both of them. And which number is lower, that's the one you buy. So I did the same for watts cost per builds and dollar cost. So for example, right here on the 5070, the watts cost per builds is just a goofy whatever number is 28.6, but it goes down dramatically with each model up. So what this means is you never, ever, ever want to buy the bottom one. Like look at the 4000 series. The RTX 4060 is 360 watt cost, and then all the way over on the 4090 is 1.9. But then I did further math to make it into a percentage. You're going to see something interesting here. Here's the watt cost on the 3000 series. This is why you never buy a 3050, because the 3050 is the baseline. It has 100%, and then everything else above that, we're seeing how many percent difference is that. So you get a 31.67 improvement on its power draw just from going from a 3050 to a 3060. And as you move up, it goes, 79%, 88. All of these numbers are compared to the 3050. Now, if we look at the 4000 series, the same story is going on here. You might notice that, I may have unlocked the secrets of NVIDIA's product stack. It's actually, once you hit 90%, that's where the price per watts is really good, because you think about it, I'm adding up all the numbers for the features on the GPU. And since there's only 4 GPUs that are for desktops right now, the watts cost is, it's still doing the same trend. But right now, the 5090, even though its TDP is 575 watts, it's still 98 more efficient than the 5070. Okay, looking at the dollar cost starting with the 3000 series, you can see the same trend here, and the 4000 series as well. But check out these speculative prices I put in for the 3050, 3060, and 3060 Ti based off of previous price trend increases for each generation. And this is what the chart looks like. So if you're going to complain about the expensive price of the 5090, wait until these MSRPs are announced, and based off this chart, you will realize that every GPU has been scaled up in price, not just the 5090, and NVIDIA makes more money on the lower models, not the higher ones. So I'm going to make some predictions. Let's see which ones of these come true. First of all, we're going to see 10 GPUs in total for desktop in the 5000 series before the 6000 series is released in 2 years. Due to the huge jump in these numbers from the 5080 to the 5090, at least one of those GPUs will land in between the 5080 and the 5090. And it'll have something like 500 tensor cores and 1600 CUDA cores, and hopefully it has 24 gigabytes of VRAM if NVIDIA wants to throw us a frickin' bone here.
Throw me a frickin' bone here.
These specs might change. And these are the ones that I could find on Tech Power Up right now. So whether or not these were leaks or NVIDIA actually told them, I don't know. But right now, there's only 7 GPUs for me to pull data about. Second, and you're going to want to write this down somewhere. Bookmark this video or something. A good budget AI GPU, bang for the buck, is going to be the 5060 Ti. Check it out. It has 16 gigabytes of VRAM, and it's comparable to the 5070. Mostly, it's got less CUDA cores, less tensor cores, but that VRAM is going to be really good. All right, let's talk about the AI capabilities of the 5000 series.
Are you going to get double the performance? Maybe for some games out there, but you're not going to get a model that is the exact same quality at that size. And this is just because they have a new type of acceleration that's come out with Blackwell. That's FP4 acceleration. And they also have FP8 on a 4090. However, comparing a FP4 on a 5090 with an FP8 on a 4090 is not a great apples to apples comparison. It really is comparing two different qualities that are substantial.
So I found the they used to call them tweets. I guess sheet is what they call them now, that he was showing in his video. He says the numbers bother him. He uses vague terms like AI tops, compares FP4 on the 5090 with FP8 on the 4090, and shows the flops. Here's the flops left and right that I found on Tech Power Up. There is an improvement on the 5090 versus the 4090 here, but none of them have FP4. And it says right here in the sheet, plot graph mixing, FP16, BF16, FP8, FP4, and then FP1 is this plot graph. And it's just saying FP4 is going to be so fast in the future. Then I saw this, and it's showing the gray is the 4090, the green is the 5090. And I saw this and I got real excited where it says flux.dev. Oh, because when I'm testing a batch of a dozen flux.dev generations to grab a good seed, it takes about 58 minutes on my 3090. And 4090, whatever time it takes, it would take half the time of the 4090 to go onto the 5090. But then you read down here, the testing was done with FP8 on the 40 series and FP4 on the 50 series. That's not apples to apples at all, because FP4 is not going to be as good of quality as the FP8. Yes, it's twice as fast, but also, yeah, it's not as good. It says, just show me the BF16 numbers. All I care about, blah, blah, blah. He uses it to train GPT-2 and Llama 3. This is my favorite comment on that post. Readers added context they thought people might want to know. NVIDIA, compare BF16 with BF16! Because ever since the 3000 series, you have that floating point algorithm, what's it to use when you're training a model, and it gives you better results than the FP16 that we were using before. And NVIDIA is spouting FP4 now? What? All right, now for the conclusion. He's scared of this. Well, he says he is. Maybe he's just trying to bait you emotionally. I don't know about this guy. I mean, I don't know. I'm not afraid of the 5000 series. I actually want some of those cards. They're going to tear through AI workloads. And not because NVIDIA democratized AI.
Democratized AI.
But because
we invented CUDA.
They released CUDA in 2006, and it took until 2012 for developers to actually utilize it. And now we've got stuff on GitHub that we can download and run on it. And about the VRAM, I wish there was more. It's about time we had more. The only GPUs that have the right amount of VRAM based off of their position in the product stack are the 5090 with the 32 gigabytes and the as of yet unannounced 5060 Ti with 16 gigs. But NVIDIA doesn't really want you to use their GPUs for AI workloads. They either want you to use what the corporations have, so they probably go into the corporations and tell them, hey, you can run AI cloud services and people can pay you a subscription, and they have to because they're not going to have enough VRAM on their consumer level GPUs. Or they want you to get their little gold box digit what's it. Oh, look, there's HBM in there. Why not in the consumer desktop GPUs? Huh, NVIDIA? Why are you not explaining this HBM stuff? Why don't we have HBM on our desktop GPUs yet? All right, here's something else I want you to conceptualize. Here's a dollar cost graph I did with all the 3000, 4000, and the currently known 5000 series, including the 5050, 5060, 5060 Ti. You could see that, the bottom one obviously is the 3050, and going up from that, the 5050 is a much better value than the 3050, but all of the other ones kind of scale. Isn't that interesting? But we get a much better idea of what I'm trying to illustrate here if we look at the watt cost for all of these GPUs for 3 generations. Look at the 5090 versus the 4090. Not much of a difference there. It's about 0.16% improvement from the previous generation. Now, compare the 3090 to the 5090, and you'll agree with me that NVIDIA hasn't made much of an improvement over the past 2 generations. Most likely what NVIDIA is doing is improving the production cost and giving you a little bit more at the same price as the last 2 generations. You might think they have a slight improvement with a newer generation graphics processor. And if you see videos stating that RTX 5090 has 30% improvement over RTX 4090, well, let me remind you that the RTX 5090 has 32% more tensor cores and CUDA cores. So in a sneaky way, NVIDIA is making more and more profit from you with each generation. You gotta keep in mind that I've noticed over the past few years, the model names mean nothing. Or the numbers or whatever, like the 90 or the 90 Ti isn't always the top one. And the middle one isn't always the same one. You got to see them all next to each other. And if you're still watching the video after this long, thank you very much. And why don't you go in the comments below and tell me what GPU you're rocking right now. I've got a 5090 in this machine, a 3060 12 gig in one of my training / generating things for Patreon subscribers, as well as a 3080 Ti in the other one. That way they have 12 gigs of VRAM. This one has 24. I need to upgrade those. What kind of GPU do you have, and what kind of upgrade are you looking forward to getting right now? And if you're still having trouble deciding which GPU to get and you need some more information, I've got a couple more videos for you. That one's for this 3060 12 gig and how I explain VRAM so important and why 12 gigabytes is a place where you need to start. Or maybe you want to look at this one down here for the 4000 series supercards, because maybe 12 is not enough and you need the next generation to get faster generations. And there's some 16 gigabyte GPUs in there for you to look at. And thanks so much for watching the video, and I'll see you in the next one.